So today we're going to be doing rates of change in polynomial expressions. So we did an intro video to what rate of change is. So we remember our average rate of change formula is our f at our second point minus our f at our first point divided by our second x point minus our initial x. So basically y2 minus y1 over x2 minus x1. That is a quick overview of that. We're going to, in this video, basically see how we can see rates of change in polynomial expressions. So let's say I have a polynomial expression f of x, which is equal to x minus 3 cubed minus 1. So what we want to do here, we want to look at the average rate of change from x equals 2 to x equals, let's say 5. So if we look at our rate of change function, it's going to be f at x2 minus f at x1 over x2 minus x1. So let's do that. Let's plug in. So our x1 is going to be 2, our x2 is going to be 5. So let's plug in our 5. F at 5 is equal to 5 minus 3 cubed minus 1, which is 2 cubed minus 1, which is 8 minus 1, which is 7. Okay, so we have 7. Let's do now our x1, which is x is equal to 2 now. 2 minus 3 to the power of 3 minus 1. So that'll give me negative 1 cubed minus 1, which is equal to negative 1 minus 1, which is equal to negative 2. So that'll give me negative 2. So if we were to write this out, we have 7 minus negative 2 over 5 minus 2, our delta. So we have 7 minus negative 2, so that'll be 9 over 5, 3, so 9 over 3 is 3, and that is our average rate of change for that particular inquiry, I should say. So let's look at one more example. Let's say I have a function. Let's say this is 4. Okay. It's a pretty rough sketch, but say we want to know that what is the instantaneous rate of change at the point 2, 0, which is right here. That's what I want to know. So, very quickly, we can actually just look at this graph and see the 3 zeros. So we can say that the formula for this is equal to a times the points, which is going to be at 0. So x, and then at 2, x minus 2, and x minus 4. And then since we know a point at which it's going to go through, we can use that. Say 2, well, if we plug in 0, all 0 is going to be one of those. So 0 will give me a 0 there. So I wonder if I can. Well, let's try using this point. I know I drew it really. Say I know that it goes through. This point 1, 3. I can plug 1, 3 into here. So I can say 3 is equal to a times 1, 1 minus 2, 1 minus 4, and that will give me one second. I'm just now realizing I missed a squared here because it is a parabolic point over here. So because it touched like that and went off, this becomes the parabolic point on the as the 0. So that means that is going to be squared at that point. Yeah, my mistake. So that should be squared as well. So continuing on here, I should have 3a negative 1 cubed. So that'll give me negative 1 and negative, sorry, yeah. Not cubed. My brain is acting up. So negative 1 squared is 1. And then negative 3. So I should get. So I can just take out this 1 and just put negative 3. So that'll leave me with a is equal to negative 1. So I can just put negative there. Just so it's 1. And now you have the formula of the sketch. So at this point, we could just write a formula for the slope that we're trying to get here. And if you remember from our rates of change formula, we're our second point. Well, and that'll give us, in our case, we're looking at the point 2. So f at 2 plus h minus f at 2 over h. So let h equal 0.001. So we're gonna have our slope is equal to f at 2.001 minus f at 2 over 0.001. And now all we have to do is plug this in. So f at 2, we know right away, if we put a 2 in there, this becomes a 0. So the whole thing becomes 0. So f at 2 is actually going to be nothing. That's a 0. But this, on the other hand, if we punch that into a calculator and put that into there, so negative 2.001, only 20 zeros. Again. If you punch this into a calculator, you actually get 0.000000450. So let's write that out here. The slope is still equal to 0.4 over 0.001, and when you divide that you get 0.004. So since we know that the instantaneous rate of change here is, because it's a 0 and it's actually doing this right here, we know that we should get about a 0. So we can actually round this down to about absolutely nothing. So we can say that the instantaneous rate of change at 2, 0 is approximately 0. And that is how we do that. So I hope that wasn't super confusing. Let me see if anybody's interested in doing a little bit of math here. Just throw it down in the comments section, whatever you get. Take f of x is equal to 3x plus 1, and then find the average rate of change on the interval from x from 2 to 5. And put it down in the comment section. And that's all for this video.